A closed cylindrical can is to contain a volume of 6,400 pi cubic centimeters. Find the dimensions of the can that minimizes the area of metal to be used in the construction and state the area. And note it's closed, so we have a circle at both ends. So let's just sketch our cylinder. And let's call this R and this H. Now the volume we know is pi r squared H, and that 6,400 pi is equal to pi r squared H. Cancel those, and I've got 6,400 is equal to r squared H, and I'm going to write that as H being 6,400 divided by r squared. The surface area is going to be the two circles, so that's pi r squared, and the curved surface, which is 2 pi r h. And of course we've got two circles because it's closed, one at each end, so it's 2 pi r squared. So that is 2 pi r squared plus 2 pi r, and h is this. So we can tidy that. So 2 pi r squared, and 2 times 6,400 is 12,800. And then we've got pi, and the r's cancel like that, giving me divided by r, or if you like, 2 pi r squared plus 12,800 pi r to the negative 1. Now we want to minimize this, so let's do ds dr. So that's going to be 4 pi r, take away 12,800 pi r to the negative 2, or over r squared. Now if we want that to be equal to 0, we get 4 pi r is 12,800 pi over r squared. Cancel the pi's, bring the I squared up here, and that's 4r cubed is 12,800. So that gives me that r cubed is 3,200, and therefore r is the cube root of 3,200. So perhaps we should give that as a decimal answer. So we have the cube root of 3,200, which gives us, let's call that 14.74. And that's in centimetres, correct to dp. Now, earlier on we had that h was 6,400 divided by r squared. So that's 6,400 over the last answer squared, which is 29.47, correct to dp. And then the surface area was 2 pi r squared plus 12,800 pi divided by r. So we can calculate that. So we've got 2 times pi times the cube root of 3,200 squared, add 12,800 times pi divided by the cube root of 3,200. And that's 4093. And that is in square centimeters. And that is to the nearest whole number.